Good evening, everyone. My name is Ganesh. I am from ECE section. Today, my topic is basic theorem of Laplace transformation. Introduction to Laplace transformation. The Laplace transformation is a powerful integral transform used to solving differential equation. Suppose any strong problems, we can we can solve easily to use this method. It converts functions from the time domain to complex frequency domain. Understanding its basic theorems is essential for effectively applying the transformation in engineering and mathematics. Uh, definition def, Definition of Laplace transform. The Laplace transform of a function it's defined as infinity, limits, and etc. It transforms a time domain function into a algebraic function of complex variable. The, the transform exists for function of exponential order with grow on faster than an exponential function. Suppose some theorems to solve difficult, and this theorem is more easy to solve the problems. Next, linearity theorem. The Laplace transform is a linear operate meaning mathematical. Uh, this this property simplifies the transformation of sums and scalar multiples of functions. It is fundamental in handling complex functions by breaking them into similar parts. First, shifting theorem. Theorem accounts for delays in the time domain. It suppose it's useful for analyzing systems with time delays. Second, shifting theorem. Frequency shift, multiplying by exponential shifts the Laplace domain function. This theorem helps in solving differential equations with exponential factors. It simplifies the analyzing of systems with exponential growth or delays. The exponential growth or delays, this theorem helps in solving differential equations with exponential factors. Differentiation in the domain. The Laplace of derivatives mathematical, uh, higher order derivatives following a similar pattern involving successful derivatives of theorems. This theorem allows the conversion of differential equations into algebraic equations. The following similar pattern successive derivatives. This theorem allows the conversion of differential equations. This is called Laplace transform of derivatives. Integration in the domain. The Laplace transformation of a integral of mathematical, suppose limits and continuities. It is useful for solving integral equations and analyzing cumulative responses. This theorem relates the integral operation in the time domains to divide division by s in the frequency domain. The Laplace transformation of integral to solve the integral equations cumulative responses. The integral operations in the time domain of division. Initial and final value theorem. The initial value theorem states limits infinity. The, the final value theorem states limits continuity, provides the limits exits. These theorems are useful for quickly determining the behavior of systems at initial and long term times. Convolution theorem. The Laplace transform the convolution of two two functions is the product of the product of the theorem product of the transforms. Convolution is in the time domain corresponding to multiplication in the domains. Summary and applications. The basic theorems of Laplace transformation facilitate solving linear differential equations efficiently. They are widely applied in control systems, signals, processing, and electrical engineering. The mastery of these theorems enable a systematic approach to analyze complex dynamic systems. Laplace transformation facilitates solving linear differential equations, um, the widely control systems, signal processing, and electrical engineering. These theorems enable a systematic approach to analyzing complex dynamic systems.